I do really yoga every night.
Welcome, ladies and gentlemen. It's great to see you guys. Welcome back. Let's go ahead and take a look at our linearization. So we can approximate function values using a tangent line, and that's what linearization is. It's a fancy word for using a tangent line to approximate function values. Let's go ahead and generate the linearization of f of x equals opposite of x at x equals 5 or 6, and we'll use it to make an approximation. So for us, first thing we need, right, is our x coordinate point of tangency, a y coordinate point of tangency, and our slope of the tangent line, just like before. In order to make a linearization, we have to know where we're going to be making it. So it looks like we're going to make it at x equals pi over 6. The y coordinate point of tangency, I'll get by evaluating my original function at x equals pi over 6. So the opposite of cosine of pi over 6 is going to be opposite of root 3 over 2, so negative root 3 over 2. Is that what you guys are getting? And lastly, the slope of the tangent line. Where will I go to get the slope of the tangent line? Danny? The derivative. So we better generate that expression. Go ahead and tell the class the derivative f prime if my original function f is opposite of cosine x. What am I going to get for my derivative? Vivian?
Sine of x.
So cosine goes to opposite of sine, so opposite of cosine will go to positive sine. Good, thank you. I'll evaluate that at my x coordinate of concern to get the slope of the tangent line. So f prime of pi over 6 equals sine of pi over 6. And the sine of pi over 6 is 1/2, less than 1/2. So we're getting a slope of the tangent line that is equal to 1/2, and I have all three pieces. So we called our tangent line now, right, L of x equals. So while we can start with the original form, y minus y sub 1 equals m times quantity x minus x sub 1, we're going to rearrange that, right, and call it L of x for our linearization. So we need root 3 over 2, opposite, so y plus root 3 over 2. And my slope of the tangent line is 1/2. So my linearization function, call it L of x, will be given by, and I'll just leave it like this, 1/2 times quantity x minus, we missed pi over 6 as our x coordinate. X minus pi over 6. Close, and then subtract over the root 3 over 2. Is that what you guys got? Subtract over? All right. Awesome. Raise your hand if you generated this linearization. L of x. Hey, that's it. Now we'll go ahead and use it to approximate the cosine of 0.5. We'll do this without a calculator, and then we'll compare it with the actual value, right, using the calculator, and determine the margin of error. So we'll go ahead and evaluate L of 0.5 simply by plugging in 0.5. So the exact, right, the exact tangent line value predicted, right, would be this. And I think I'm going to leave it there so that I can compare. And I'm going to leave it there so that I can compare. And then I'll go ahead and, well, I guess I could make it a little prettier. Is that half of a half would be a quarter minus pi over 12? Well, I'll just leave it. Now we'll go ahead and compare that with the actual one. So to the emulator, yeah, don't mess that up. Don't mess that up, Tiger. All right, so now I'll go and I'll compare that with the original. So my linearization predicts a value of cosine of 0.5 that is 1/2 times 0.5 minus pi over 6, close, minus root 3 over 2. How many mistakes did I make in that one line of entry? Okay, is that right? Yes, yes. Prediction? Negative 0.8778. And actual value? Well, rounded. Is cosine of 0.5. Survey says? Uh-oh. What did we do wrong? Oh, opposite of cosine x is my original function, f of x. That's an easy fix. So let's get that up there. Opposite of cosine of 0.5. Sorry. So for this right here, we needed that.
Doing it on the calculator.
That's interesting. So can we try that? Okay. Nope, not gonna let me. That's fine. All right. So I think we got it all now. What do we need? We need this and that, and now we'll go ahead and compare. So it looks to me like our, oh my gosh, that's pretty good. So our difference between the actual function value and our predicted how many messes up did I get there? Close enough? Hey! 0.0002422, so that's pretty darn good. So that's very nice. So we can see that our approximation is very good. Okay, so then one thing that I wanted to add to our concept and skill guide after I completed it and did the printing yesterday after school was, so what makes a linear approximation good, right? What makes my linearization a good approximation? What kind of factors would make that a better approximation versus a worse approximation? And so what's going to happen to this approximation if you consider using it to approximate opposite of cosine of 0.6, opposite of cosine of 0.7, right? So when is this approximation good versus when is this approximation bad? Under what circumstances does it not make sense to use linearization? And so on and so forth. And so I want you to consider those things with your partner as you work and review later on today. All right, let's go ahead and take care of our housekeeping. So we've got our Unit 3, OTL number 6. At this time, I'd ask that you staple multiple pages together, and I'll pause the recording and give you an opportunity to do that. So ladies and gentlemen, I wanted to point out that the exam format has changed slightly for the 2016-2017 school year. The AP exam will still consist of the two parts equally weighted, multiple choice and free response. However, the multiple choice portion has changed now. Instead of having the 28 non-calculator questions on part A and 17 calculator allowed questions on part B, it switched to 30-15. Still 45 questions, but the split now is slightly moved to more calculator not permitted questions, okay? This is following the trend when the redesign several years ago of more non-calculator items. Check out the free response. Remember, there's 2 calculator allowed to start the party, and then 4 non-calculator for the remainder of the time. So still 6 questions there, but notice how there's more questions that are non-calculator. And you kind of have seen that, right? Our emphasis here with our non-calculator analytical work. Now, we still need to be able to use those same built-in 4 capabilities of our grapher that we saw last year in AB, but we kind of see how the split's going there. All right, so what are we going to do today? Well, we've got a brand new free response question that has been released as a result of the reformatting this year. They're focusing on mathematical practices on the AP exam. The good news is that you guys already have done a lot of practice with this, working towards justification and explain your reasoning, right? And tell why or why not in your answer. And so a lot of the free response type practice we've done is going to transfer very nicely to the new framework. There's a newer free response question involving related rates, and so now is a perfect time because this unit is going to have related rates questions on the test. And so what we're going to do is use this as a practice exercise and get double the bang for our buck. So we're going to use it, 1, to practice with AP and the AP exam format, and 2, to practice reviewing for your Unit 3 test. That will include related rates questions on Thursday. So what we're going to do is we're going to go ahead and complete this in partner pairs. You're not going to do it individually with my stopwatch timer, right? We're going to save that for our April. Oh yeah. Our time testing in class. Right now we're going to complete in partner pairs. Again, our averages want to be 15 minutes, so we're going to go for 12 minutes just to have a little bit less time so you get used to kind of working faster. It's going to be calculator allowed, but you're going to leave all answers exact. And so you'll have access to your calculator for this particular one. They didn't specify. You're going to have access to your calculator, but leave all answers exact, like if there's a pi in it or whatever. And then your scoring guidelines will be used to score and make corrections. You'll get that at the end of the 12 minutes. And then we'll do our stamp check, and then you'll have a review time. So does everybody get what the next section looks like? So we're going to do 12 minutes. I'm going to distribute those. And you can work with your partner. Just try to keep it in your partner pairs, and at the end of 12, so we'll come back together at 45. I'm going to be able to you'll be able to score this and make corrections using the actual AP scoring guide. Thank you, guys. Go ahead and get started as soon as you get it. It's just a practice exercise, but it's a good review, I thought. And it's fresh out. Thank you. Fresh out this year. Thank you. So go ahead and work with your partner there. And I'll pause the recording.